Hi everyone, today our group will be presenting our project, the Gaming Score Leadership System, for the subject BITP 10123 Data Structure and Algorithm. We are BITC student and our group consists of members from the two sections, which is S1Z1 and X1Z2. So moving on, let me introduce my group members. First of all, we have Natasha Nabila Anak Mazi, Maisara binti Muhammad Nur, Freda Nelson Pius, Kingston Wing Scott, Nurul Nazira binti Abdul Rahman, and Nurul Natasha binti Razali.
So, this is our group task distribution.
My name is Natasha Nabila and I will be presenting for the introduction and project descriptions. Gaming Score Management System, a console-based application developed in C++ designed to track and manage player score in a structured and efficient manner. This system allows users to store player names, generate a ranked leaderboard, and search for any player by name, demonstrating how classical algorithm can be applied in a practical, real-world context. The primary goal of this project is to build a fast and organized solution for ranking and retrieving player data. The system flow is straightforward. The user input player names and their corresponding score. The system then automatically ranks the score to produce a leaderboard, and any player can be located by name in a matter of seconds. At the core of this system are two fundamental algorithms, which is bubble sort, used to arrange score from highest to lowest, and binary search, used to efficiently locate a specific player by names. So, what problem does this project solve? Managing a large number of player score manually is simply not efficient. Finding a specific player one by one is slow, and without a proper structure, ranking score accurately becomes a challenge. To address this, we define three objectives: storing and managing player data efficiently, using bubble sort to rank score from highest to lowest, and applying binary search to locate any player quickly and accurately. These three goals form a backbone of the entire system.
My name is Natasha binti Razali. I will explain about our system architecture diagram. The diagram shows how the internal components of our gaming scoreboard system work together. It explains the relationship between the main program, the score class, the function, the algorithm, and the data structure used. At the top is the main program. The main program is the starting point of our system. It displays the menu, accepts the user choice, and calls the appropriate function based on the selected option. Next, the main program communicates with the score class. The score class is the main class that contains all the functions used in our system, which manage all player information. It contains the array and all the functions needed for the gaming scoreboard system.
First function is the insert. The insert function is used to add player's name and score into the array-based list. If the list is not full, the function will be stored in the correct position. The second function is display. The function displays all the players together with their score in a table format. Third, we have find players. The function search for a player's name in the array. Our project uses linear search, which takes each player name one by one until the target player is found or the end of the list is reached. The last function is rank player. The function sorts all players' score from the highest score to the lowest score. To perform the shortest process, we use the bubble sort algorithm. Bubble sort works by comparing two adjacent scores. If the left score is smaller than the right score, the two scores will swap. The process is repeated until all players are arranged from the highest score to the lowest score. Finally, at the bottom is the array-based list, which is the main data structure used in our project. Our system stores players' information using two parallel arrays, name and score. Both arrays share the same index. For example, if name at the index 0 is mine, then score at the index 0 is 85. This means my score is 85. Next, we have user flow diagram. This shows the sequence of action performed by the user will interact with our gaming scoreboard system. First, the program starts and displays the main menu. At this stage, the user can choose one of the 5 available options. Option 1, add player. If the user selects add player, the system asks the player's name and score. After information is entered, the new record is stored in the array-based list. Then, the program returns to the main menu. Option 2, display all player. If the user chooses display all player, the system display every player's name together with their score. After displaying this list, the system returns to the main menu. Option 3, rank player. For rank player, the system sorts all players' score from highest to lowest using the bubble sort algorithm. Once the ranking is displayed, the program returns to the main menu. Option 4, search player. If the user selects search player, the user needs to enter a player's name. The system searches through the store record using the search function. If the players exit, the player information will display. Otherwise, the system shows the players not found. After that, the program returns to the main menu. Option 5, exit. Finally, if the user chooses exit, the system terminates the program and the execute ends. from option 1 until 4. After the operation is complete, the system will return to the main menu so that the user can perform other operations.
Next, I will explain how bubble sort works in our gaming scoreboard system. Bubble sort is the sorting algorithm we use to rank players based on their scores. In our project, the players are sorted in descending order, which means the player with the highest score will appear at the top of the scoreboard. The process begins by reading the player data store in the arrays and determining the total number of players represented by n. Then the outer loop starts with I equal to 0. This outer loop controls the number of passes needed to sort the entire array. Inside each pass, the inner loop begins with j equal to 0. The algorithm compares two adjacent scores, which are aj and aj plus 1. The current score is less than the next score. It means the highest score should come first. Therefore, the two scores are swapped. However, in our system, each score belongs to a specific player. So when the scores are swapped, the corresponding player's name are also swapped. This ensures that every player's name always matches the correct score. After each comparison, j is increased by 1, and the algorithm compares the next pair of adjacent scores. This continues until the end of the current pass. When one pass is completed, the largest remaining score has moved to its correct position. The outer loop then increased by 1, reducing the number of comparisons needed in the next pass because the last elements are already sorted. The process repeats until all passes are completed. When reach n minus 1, the array is fully sorted, and the players are displayed in ranking order from the highest score to the lowest.
Hi, my name is Nur Nazra binti Abdul Rahman from S1G2. I'll be explaining part linear search. For searching player's name, our system will use the linear search algorithm, where linear search works by checking each player one by one from the beginning of the array until the target is found. Once the target is found, the algorithm will return to the player's position. Meanwhile, if the algorithm reaches the end of the list without finding a match, it will return to -1, which means the player does not exist in the scoreboard. For example, if we search for the player Shah, the program first compares with Mai and Shah, then with Fred, and finally Shah at the index number 2 is found. Once a match is found, the search stops immediately and returns to the position. The reason we choose linear search because it is simple to implement and works well with our array-based list. Meanwhile, binary search requires the data to be sorted according to the search key. Our project search player's name directly, so linear search is the most suitable for our current implementation.
Hello everyone, my name is Kingston Doing Scott, metric number B0325-10215, and right now I'll be explaining about the program menu. So let's get started. First, take a look at the main menu of our gaming scoreboard system shown here on the screen. As you can see, this is a console-based menu that gives the user 5 options to choose from. You have to add player, display all players' name, rank players by score, and also search player and exit. Each of these options corresponds to the specific function inside my program, and together they represent the core operations of an array-based list. The first option, add player, allows a new player's name and score to be inserted into the list. Behind the scenes, this calls an insert open bracket close bracket function, which always places the new players at the end of the current list by using the total number of items as the insertion position. The second option is the display all players. Prints out the entire list in a neatly formatted table, showing each player's rank, name, and score. This relies on a loop that goes through the array from beginning to the end, with some additional spacing logic to keep the columns aligned. The third option is rank players, is where bubble sort comes to play. Selecting the option reorders the entire list so that the player with the highest score appears first and the lowest score appears last. The fourth option, search player. It lets the user to look up a specific player by name. This uses linear search, which scans through the array from the front until it either finds a match or reaches the end of the list. And finally, the fifth option, which is exit. Basically, it safely ends the program. What's worth highlighting is that the menu isn't just shown once, it's wrapped inside a do-while loop, so after every action, the same 5 options are displayed again. This means that the user can keep adding, displaying, ranking, and also searching players continuously without ever needing to restart the program until they specifically choose to exit the program. Hello everyone, so now let's continue with the expected output of the program, which you can see is captured here across 4 screenshots, starting with option 1, add players. The output shows 2 players being added, one after another. The first is a player named Kingston, is added with a score of 90, and the program confirms this by displaying Kingston inserted successfully at position 0. Right after that, a second player named Ray is added with a score of 60, and the program confirms Ray inserted successfully at position 1. This output proves that the insertion logic is working correctly, with new each player being placed at the next available slot at the end of the array. Moving to option 2, display all players. The output shows both players listed in a clean table format with columns for rank, player names, and score. Here we can see Kingston at rank 1 with a score of 90 and Ray at rank 2 with a score of 60. This is simply the list in the order of the players we originally added, displayed using the formatted table layout. For option 3 is the rank players. The output confirms that the players have been ranked by score from highest to lowest. In this case, since Kingston already has a higher score than Ray, the resulting order stays the same. Kingston remains at rank 1 with 90 and Ray remains at rank 2 with 60. This output still demonstrates that the sorting function executed successfully, even though the visible order didn't need to change. Lastly, for option 4, which is to search players, the output shows a search being performed for the name Ray. The program response with Ray was found at position 2, which confirms that the linear search function correctly scanned through the array and located the player, reporting their current position in the list. Together, this full output confirms that each core function, insertion, display, sorting, and searching is working exactly as intended on a simple two-player dataset. Thank you. Hello everyone. So now let's talk about the conclusion and future enhancement. To conclude, this project successfully demonstrates an array-based gaming scoreboard system that supports inserting, displaying, ranking, and searching for players. Through this, I was able to apply two core algorithms, bubble sort for ranking and linear search for lookup, onto real data, including edge cases like tight scores. Overall, this project shows how fundamental data structure concepts can be applied to build a simple functional leaderboard system. Now let's head straight to the future enhancement. There are a few improvements I'd like to add. First, a delete or remove player function, since the current system only supports adding players, not removing them. Second, an update or edit function, so a player's score can be corrected without having to re-enter the whole list. And lastly, file saving and loading, so the scoreboard data persists between program runs instead of resetting every time the program closes. Thank you.
My name is Fredo Nelson Pius, and now I will run the actual program to show how it works. This is our gaming scoreboard. It led us to add players, display all the players that has been added, and rank players from highest score to the lowest score, and then to search players within the list. So first, let's add a few players to the leaderboard. We'll add Amir with a score of 75, Hakim with a score of 92, and Danish with a score of 60. Each time we add a player, the program inserts them at the end of the list and confirms the position. So let's display the current list by typing number 2. As you can see, the players are shown in order, but they are not yet sorted by score. So next we'll rank the players using the bubble sort. To rank them, we will have to type the number 3. So the program sort the score from highest to lowest. Hakim is now ranked first with a score of 92, followed by Amir with a score of 75, and Danish with a score of 60. Behind the scene, bubble sort compares adjacent scores and swaps them whenever they are in wrong order. This process repeats until the entire list is sorted. The player's name is swapped together with the score so that the data remains accurate. Now let's search for a specific player using a linear search. We will search Hakim. The program scans through the list from the beginning and successfully finds Hakim at position 1. So let's also search for a player who is not in the leaderboard. We'll search for the name Faris. Since Faris is not in this list, the program checks every player and correctly returns not found. This demonstrates that the search function handles both successfully and unsuccessfully searches correctly. That covers adding players, displaying the leaderboard, ranking players from highest to lowest score, and searching for players using linear search. So that is all from me. Thank you.